Austin's going to explain to us how he did the bell ringer. Let's pay close attention. That way, in case anybody made a mistake. Austin, go ahead. And make sure you read the numbers and stuff out loud, because those on Google Meet cannot hear or see what's written on the board.
I carried the X and Y down and got 3 equals 2 plus 3. And then I got 3 equals 5. And I said, no, it is not a solution.
Okay, awesome. Brandon, tell us, do you agree or disagree?
I disagree.
Hey, how come?
When you put in the 2, you're supposed to keep the 4, -4, and to multiply the 2 to the -4. I think that's very messed up.
Okay, you think it might look something like he may have plugged it into the equation that we were working on in our notes yesterday, x plus 3. Yeah, so you would just plug, instead of plugging it into the -4x plus 11, I think you just accidentally plugged it into yesterday's equation, like when you were looking off of it. All right, so go off of that equation. Y equals -4x plus 11, and it would be 3 equals -4 times 2 plus 11. Okay, what's -4 times 2?
-8.
And what's -8 plus 11? +3? Okay, so you get 3 equals 3. How about now, do you think it's a solution?
Yes.
Yeah, perfect. So you did all your math right. It was just when you plugged it in, you were looking at yesterday's equation rather than the bell ringer. Perfect. All right, what questions do you have for me on the bell ringer? All right, once you've made your corrections, you can go ahead, pass it to the front row, pass it to the right, and then you need to get out your notes from yesterday, the solving systems of equations by graphing. All right, so my question to you is, I need you to pretty much give me, let's say I was gone yesterday. I'm your classmate. I was gone yesterday, and I need you to kind of explain to me what we did yesterday. How do I solve a system of linear?
Teachers, if you would let the students on the list for decorating come on down, please. Thank you.
If you could tell me what we did yesterday, kind of like in a couple statements, and pretend like I'm a student that was not here yesterday. Aiden, what would you say we did yesterday?
I would say we basically did what was normal, but the plugging application, but for X and Y, we plugged in for both X and Y.
Okay, so we're used to substituting, so we plugged in for X and Y. Why were we plugging in for X and Y? What were we doing?
So we would see if they equal each other, like, so the Y is equal the side of the image, so to speak.
Okay. Brianna, you want to add to that a little bit?
I was going to say that we have a solution, and instead of like substituting, you would take 2 and 3 and plug in for X and Y, and then you add what's on the right side, I guess, and whatever, say like the answer's like 5 on for Y, and if you get like 8 on the X, then it would be the solution.
Okay. All right, so you're saying we would plug in pretty much what we did on the bell ringer, but we would have to plug it in for both of them,
Yes.
and it would have to be true for both of them. Rebecca, would there be anything you would like to add to someone that was not here yesterday? Cody, anything you would like to add?
Well, I'm still a little bit confused on the subject, so I don't think I can really help someone else.
Okay, so far they've said we plugged in, pretty much what we did for the bell ringer. We plugged it in and see if it was a solution for both, and it had to work for both. Is there anything else that we did yesterday?
You graph to find out how it would become graph and how lines would intersect to find out what it is.
Okay, so like we grabbed 2 equations to see where they intersected, to see what the solution was. Okay. All right, yeah, very good. So so yesterday, so what the first thing we did was check to see if a ordered pair was a solution to a graph. To see if an ordered pair is a solution, you can either plug it in and make sure that it's true, or you can graph this and see if that ordered pair is on the line. Or, I don't know if these calculators do it, but give me just a second. No, if you had your graphic calculator,
I
I
have
can
a
show you.
graphing calculator.
Do you have a graphing one?
Yeah.
Let me. Okay, if you were to have a graphing calculator, you could type in y, go to y equals, and type in negative 4x plus 11. And you can graph that line, you know how we did before. Let me go to step y and turn this off. 4x plus 11, graph it. Okay. I graph negative 4x plus 11 on here. You could trace the line and go to 2 on the x and see if it's at 2, 3, which it is. It's at the ordered pair 2, 3. Or you could also go to the table. Sorry, calculate. Okay, you could go to calculate, and where it'll flash x equals, I can type in 2, and it tells me that y equals 3. So it tells you the ordered pair 2, 3. I could type in x equals 4, and it tells me that y is negative 5. So if I were to plug in 4 into this equation, I would get negative 5. If I were to plug in 20, let's do 10. If I were to plug in 10, I would get negative 29. Okay. So you could either plug these in, see if it's true, or if you have a graphing calculator, you can graph it and then hit calculate, and type in the x and see what y is. So that's just another benefit of having a graphing calculator. A lot of this math that you do by hand, your calculator can do it for you very quickly. All right, and then the next thing we did was, what if I did not want to go through and just plug in random ordered pairs to see if it was a solution to a system? So what we did was we graphed it. So like we had y equals negative 4x plus 11. I would graph that line. One, two, three, four, 1. 1, 2, 3, 4, 1. And I will draw that line. And what this does is it shows me all the ordered pairs that are solutions to that equation. So this ordered pair 0, 11 is a solution. This ordered pair 1, 7 is a solution. This ordered pair, which is 2, 3, is a solution. So all of these ordered pairs are solutions, plus all the ordered pairs in between those are solutions. Now, what we had was, instead of just having one equation, we had another one. Let's say it's y equals 2x plus 5. Y equals 2x plus 5. What I would do is graph this line also to see what ordered pairs are solutions for this line. So it crosses at the 5, and then you go up to over 1, up to over 1, and draw your line. Now, all of these are ordered pairs to this equation. So like this ordered pair 0, 5 is a solution. This ordered pair here, 1, 7 is a solution. This ordered pair here, which is 2, 9 is a solution. Now, your goal is to find the ordered pair that they have in common. So what ordered pair is a solution for both? The 1, 7. So 1, 7 is your solution to the system of equations. Okay, so that's what we did yesterday. You're trying to find the one. Well, there's different possibilities that you could have as solutions. We've seen possibilities where there's one solution. You told me about a solution yesterday, or about a possibility where they could be parallel. Let's say I had y equals 2x plus 5 and y equals 2x plus 6. That's this orange line here. How many ordered pairs are the orange and brown line going to have in common? None. So this right here, we would write no solution because they don't have any ordered pairs in common. Okay, there's another situation you could have where when you go to graph it, 2x plus 5, and then let's say I wanted to graph, let's say they gave me y equals 2x plus 5 and negative 4x plus 2y equals 10. You can graph that using intercepts, or you can put it in slope-intercept form, add 4x over, you get 2y equals 4x plus 10. Divide everything by 2, you get y equals 2x plus 5. Notice it's the exact same line that's right here. And so you would just graph it directly on top of that one. If that tends to happen, which is very rarely where they're the exact same line, that would be infinitely many solutions. That's because they have infinitely many ordered pairs that are solutions to both. But I believe the ones you're going to do today all have one solution. You won't have any of the special cases where there's no solution or infinitely many. I don't think. Okay. Hopefully, after yesterday's lesson and over that review, and then with today's practice, you will get better at solving systems of equations. You will need to remember how to graph a horizontal and vertical line. Remember Hoy-Bucks? Horizontal lines have a 0 slope, and it's always y equals a number, and they look like this. Vertical lines have an undefined slope, and it's always x equals a number, and they look like this. So if it's like y equals 2, y equals 3, y equals 4, it's horizontal. If it's x equals 2, x equals 3, x equals 4, it's vertical. Remember to write your answer as an ordered pair. And then you're going to have the rest of class to work on this. I would like for you to turn it in by the end of class. I think there's only 8 problems. However, let's just make it due at the end of class for now. There may be extenuating circumstances.